Hey, my name is Shariar and this is our group Goldberg machine assignment. Now my other group members are Fizzer, wave to the audience, right here, and Sohaib, who's behind the camera. Now, basically our machine isn't that complicated, it's actually quite simple. First we're going to roll the ball, which is going to cause these CD cases to fall down and the books to fall down, which in turn causes the scissors to close, which cuts the rope, which is directly connected to the weight hanging on the fan. The weight drops down right on the button right here, and it actually activates the fan. Now, the wind with the fan blows, it actually causes the parachute material to flow back, therefore rotating the rod. When the rod rotates this way, it actually hits the basketball located on the other side. The basketball will fall off and will bounce off this ramp in the cart. The cart is supposed to move forward, and the weight hanging on it is supposed to go down. When the weight goes down, the string directly attaching to the switch also causes the switch to go down as well, which in turn closes the
go. Okay, guys, as you can see, the lights are turned off. And when our roof holder machine works, it's going to turn off that light. So here we go. Okay guys, as you can see, the lights are turned off, and when our roof roller project is going to work, it's going to turn that switch on, while the lights turn on. So 3, 2, 1, go.
Why did it want to know? I was fighting.
Okay guys, as you can see, the lights are turned off, and when our roof Goldberg machine is going to work, it's going to turn on that switch, causing the lights to turn on. So 1, 2, 3, go. Yes it is. Freaking shit. I'm not joking, this is your fault, Sugar.
Yeah, definitely.
3, 2, 1, go. Okay guys, this is the 5th trial, and as you can see, the lights are turned off. And our roof Goldberg machine is going to turn that light off. I'm going to turn it on, causing the lights to turn on. So 3, 2, 1, go.
So at the end, we don't
Action.
It's our first trial. Yeah, first trial.
Please, go. No. Oh, it
Okay, let's review all the energy transformations once again. Number 1, we have the CD cases knocking over the books. It's a form of kinetic energy. Then we have the top of the books falling on a pair of scissors. It's a combination of gravitational potential energy and kinetic energy. Then you have the handle of the scissors coming together, which causes the string to break. That's a form of kinetic energy. Then you have the weight suspended by the force of tension. I repeat, not friction, tension. That was my mistake. Which causes the string to fall and therefore the weight to fall on the fan button. The switch of the fan completes the circuit of the fan, which allows electricity to flow. Therefore, electrical energy is also utilized. The electric energy of the fan causes the wings of the fan to rotate. That is also a form of kinetic energy. Furthermore, the rotation of the wings of the fan causes the air molecules to move towards the parachute material. Then the air molecules collide against the parachute material and cause the rod to rotate. This is also both of them in forms of kinetic energy. Then you have the rotating stick, which pushes the basketball and moves it from its position. While moving, the basketball moves towards the end of the table and it actually falls down. Now, a moving basketball is obviously a form of kinetic energy. However, when it falls from the table onto the ramp, it's actually a combination of gravitational potential energy and kinetic energy, since it's at a height and it's also in motion. Then, finally, it drops on the ramp. Now, when it bounces off the ramp, there's another form of energy which is utilized, which is known as elastic potential energy. And then when it collides with the cart and causes it to move, it's obviously an example of kinetic energy. The mass suspended on the cart falls from its height, which is obviously an example of gravitational potential energy, since the height factor is involved. And the switch is activated by the hanging mass, and it causes the electricity to flow, which causes the lights to turn on, and that is an example of electric energy. Now, there are many different energy transformations which were used. However, I would recommend that you keep in mind the fact that after every collision, after every single movement or every single change in form, energy was always lost in different forms such as sound or heat or in many different forms. The amount of energy between each step was gradually reduced. That's why the initial energy which we inputted is not exactly the same as the final energy which was actually produced by the entire machine. Thank you.